All right, in this video, we are going to take a look at 6.30, the problem from our book. Okay, it says a variable has the density curve whose equation is y equals 1 for 0, x between 0 and 1, and y equals 0 otherwise. Part A, graph the density curve of this variable. Okay, so on the test, I'm not going to make you graph the density curve. I'm just going to give that to you um, for a problem like this. On other problems, you might have to draw the density curve yourself, just a rough sketch of it. But this problem involves calculating the area underneath the density curve. So for that you need an accurate drawing, and if for a problem like this, I'm not going to make you draw it that accurately. So, but like I said, you might have to sketch on some of the future problems. Just drawing a rough picture of what the density curve looks like might help you. Okay, so I'm going to go ahead and graph the density curve. I've already done that on Desmos. This is what it looks like, right? So y equals 1, it just looks like this, and that's it. Okay, and again, we're only doing the part from 0 to 1, so that's kind of why I have it from 0 to 1 like this. Okay, so that's part A. It says show that the area under this density curve to the left of any number uh, x between 0 and 1 equals x. Okay, we can do that, I guess. Um, so they're just saying that, and here I'm going to turn on the shading, how I shade this under. So for instance, what they're saying there is that if I just pick any number in between 0 and 1, say like 0.5, a half, right? And look at the area underneath the density curve, right? So here's the density curve and the x-axis right here. Between those two numbers, 0 and a half, right? That if I calculate the area of this green shaded region, it's going to come out to be a half. And if I put, let's say, this at a quarter, it's kind of hard to see that until I zoom in. Let's just go with 0.2 since that's marked and I don't have to mess around with the axis. If I put, if I look at this area from 0 to 0.2 underneath the density curve, well then the area of this green region is 0.2, the same as this number here. If I put it at 0.4, then the area of this green region is 0.4. If I put it at 0.6, well then it is 0.6. Okay, so that's what they're getting at, and in part C there. I'm not going to ask you to prove that or anything like that, but it's really easy here because the area of these rectangles, right? These are rectangles, right, that we're talking about here, and the area of a rectangle is area equals length times width, right? And for all of these, one of these, either the length or width, however you want to say it, is 1. So let's just say every one of these rectangles, right, that we have is the length, right? So it's 1. And so if you make the width 0.6, well, then the area is just going to come out to be 0.6. If you make it at, if you put it at 0.4, right, well then the length is still 1 and now the width is 0.4. So you can see, right, wherever you put this right hand endpoint, the area of this green shaded region is going to be the same. Okay. Okay, so that's what they're getting at part B. Part C and D are more like the questions that I'm going to ask you on the test. What percentage of all possible observations lie between 1/2 and 3/4? Okay, so I'm going to sketch that out. 1/2 and 3/4. All right, so what we're asking is find the area, right? The way they asked it, what percentage of all possible observations of the variable, or what's the probability that an observation of the variable falls between that range, 1/4 to 3/4, would be the area between the density curve and the x-axis between 1/4, which is 0.25, right, and 3/4, which is 0.75 right here. So it would be the area of this little rectangle right here. So that rectangle, like I said, has a length and the width, right? That's the formula for length and width. We know that the length, right, or width, whatever you want to call it, we'll just call it length of this rectangle is going to be 1. All right, and then now what we need to do is to find the width here, right? So the width, let's see, I can't write on this. So let's see if we can, no, that's not gonna help. Let's go with 0.25. Let's see if that helps. Put it in the wrong spot. Okay, there we go. That's better. Okay, so we can see that the width, right, of this rectangle will start here at 0.25 and go all the way to here. So what we need to know is how far is it from here to here? Well, that's pretty straightforward, right, because that's just subtraction, right? We would just do 0.75 minus 0.25 right here. All right, so this width is 0.5. And so the length, the area of this rectangle, right, with length 1 and width 0.5 is 1 times 0.5 using the area equals length times width formula. Okay, and so that's what we wind up with for that one, 0.5. All right, the next question is what percentage of all possible observations of the variable exceed 7/8, right? And so what we would do is, again, we're looking at this density function. And we know it starts at 0 and goes to 1, like this. And so 7/8 would be somewhere here to the left of 1. And so what we would do is find the area of this shaded region, like that. Okay, so over on Desmos, we could draw it out pretty nicely by doing this, okay? So the probability or percentage of observations that exceed 7/8 would be the area between the density curve and the x-axis between, right, where 7/8 is, which is right here, and 1 on the density curve, okay? Because the density curve only goes up to 1. It's 0 over here, so obviously there's no area over there, okay? So we're finding the area of that little rectangle. So for that little rectangle, we know, right, area equals length times width. And the area is, or the length rather, is equal to 1. We know that. So looking over here at our picture, right, we've been taking this as the length, and that hasn't really been changing at all in this problem. All right, next up is, oops, if I try to write there, it will not let me do that. So, okay, so next up is the width. How far is it from here to here? So what we would need to know is what's the distance between 7/8 and 1. So this is going to be the width right here. So to do that, again, it's just subtraction, right? 1 minus 7/8. You can do that as a fraction or a decimal. It doesn't matter. I'll just go ahead and do it as a fraction since I'm just right here, and it's really just as easy. Get a common denominator, right, to subtract a fraction, and 1 right? Written as an eighth is 8/8, right? And so now that I have a common denominator, I just subtract those two and get 1/8. So the width, right, is 1/8. So multiply those two together and get 1/8. And that's the answer on this one. So 1/8, or as a decimal, right, that is, what is it, 0.125, right? Okay, and that's it on this problem.